What I'm going to talk about is something that probably most of you know very little about, the details. You may have heard some of the things that I'm going to talk about. How many here know what an excitotoxin is? Okay. So it's nice to see that so many people are coming to hear about something and have no idea what it's even about. But you're curious because primarily the second part of the title of the book, Excitotoxin, The Taste That Kills. And I'm sure you're curious as to what taste can kill you. Well, we're going to find out. If you could dim most of the lights except for this one over the podium, you can see the slides maybe a little better. An excitotoxin is exactly what its name says. Most people know what a toxin is. A toxin is a poison. Exciting is something that excites you, causes excitation. And an excitotoxin basically is any substance that causes brain cells to become very excited. And they start firing their impulses very rapidly. And they fire so rapidly that this cell will become exhausted and die. This occurs over about an hour's period. So if you take some brain cells and you put them in a petri dish and you expose them to these excitotoxic substances, the cells start firing real rapidly. But they look normal during that 1 hour period. You look at them, they look perfectly healthy. And then at 1 hour, they just suddenly die. And this is going on in your brain if you take these excitotoxins into your body. It does the same things. There's particular cells inside of your brain that will become very excited. And they'll become excited to the point that they'll die. But it's not all the cells of the brain, it's just particular ones. Now, in Matthew 13:34 through 37, it says, "For out of the abundance of the heart the mouth speaks. A good man out of the good treasure of his heart brings forth good things. And an evil man out of the evil treasure brings forth evil things. For by your words you will be justified, and by your words you will be condemned." And we're going to find out how that pertains to the subject of excitotoxins. Because at the present time, excitotoxins, the subject of excitotoxins, is the hottest idea and item going in the field of neuroscience. That is the study of the brain and the nervous system. Every journal that has anything to do with the brain and the nervous system is filled with articles about excitotoxins. Every research laboratory that is dealing with the diseases like Alzheimer's disease, Parkinson's disease, Lou Gehrig disease, Huntington's disease, all these terrible diseases of the brain, the number one thing that they're talking about is excitotoxins. But with all this flurry of activity and the fact that they have named this the decade of the brain, that we're going to concentrate all this money and all this effort in studying how the brain works and solving the problem of these terrible diseases of the brain. Despite all of that, hardly anyone in the general public has ever heard the word excitotoxin. And that's not by accident. It's because the number one source of excitotoxins in our society is in your food. And it's not in your natural foods. It's being added to your food by the industry that processes foods. And they're adding it in very large concentrations. And we'll see exactly what these excitotoxin substances are and the various deceiving methods they use to keep you from knowing they're there, and what they try to do to those of us who are trying to tell you they're there, and what they do to you. Now, what I have found out since I wrote this book, and this book was a very difficult thing to write. I went through a long period before I ever decided to do it, because I was warned by people who had dealt in this area before when I told them I wanted to write a book. One of the persons who first tried to start in this crusade, he said, "Well, that's fine, but let me warn you something. You're going to come under attack like you've never dreamed of." He said, "Ralph Nader," most of you I assume know Ralph Nader, the consumer advocate. he became interested in this at one point, just one segment of it. He was so browbeaten and so destroyed by this industry, he said he would never touch it again. And I talked to his attorney, Jim Turner, who told me this story. He said they were through with it. And this is a man that took on General Motors. So it's something that is not a light thing to take. So I was warned. Said they have hundreds of millions of dollars they will spend to keep you from getting this story out. They will threaten lawsuits. They will intimidate you in every way imaginable. So if you do this, be prepared. And so when I wrote the book, I said, what I'm going to do, I'm going to make this argument so tight, so well referenced, that no one can refute it reasonably. So I spent a long time going through hundreds and hundreds of research papers, interviewing the person who coined the term excitotoxin. And then I wrote the book. And ironically, all these terrible things that were supposed to happen never came about, except a couple of times. But I was able to handle that because I had some secrets that they didn't know, that God let me know about. Interestingly, no major publication will write about this. Your major magazines will not carry stories about it. I've never been interviewed by a major magazine. I've had 60 Minutes call me and wanted to do a story and spiked it. That means they cut it out. I had a writer for the Wall Street Journal editorial page who dared to write about how the story was spiked, and they took him off the editorial page and put him in a non-public office. Had one of the talk programs that's kind of like hard copy that's no longer around. They did an interview. We set up the story. The reporter worked with me. They fired her and canceled the program. The Chicago Tribune newspaper, when I did my first big conference on excitotoxins, the reporter was sitting in the audience. I presented the case for excitotoxin dangers. He attentively listened, and he told the person next to him, who happened to be a friend of mine, that this is the most unbelievable thing I've ever heard in my life. He said, this is terrifying. When the article came out in the Chicago Tribune, he quoted some of the things I've said, and then the rest of it was quoting the industry representatives, which said things that the writer knew was not true. And so I wrote him a letter. And I said, you sat in the audience, and you heard all of the evidence I had, scientific evidence, that their reputation and defense of its safety was not true, yet you still wrote this article. I said, I can't tell you what to write, and I know the pressure you're under, but you're going to have to live with the thought of all the damage you've done to children, pregnant women, everyone in this country because of what you've done. And it's because his newspaper was heavily advertised in by General Mills and all the food manufacturers in Michigan. So there's enormous pressure to keep this story quiet. Luckily, I've been on the 700 Club several times. They have carried the banner in this. I've been on about 7 times. Hard Copy did a thing on the NutraSweet and the pilots, airline pilots that were drinking NutraSweet that were having seizures. They were becoming so confused they couldn't figure out how to land their airplanes. We had one pilot just totally could not figure out, and his co-pilot had to land the plane. There's over 600 pilots now who have come secretly to organizations to tell their stories of the problems with NutraSweet. I've done about 40 syndicated radio programs. That's basically the way we're getting this story out, is through the radio programs and the 700 Club. They're the only people. And the ones that are most interested, I find, are the Christian radio stations, because they're not afraid. Health food magazines generally will not touch this story because they sell these things in their health food stores. and call it health food. Now, a lot of things in the health food store are fine, but they're putting some items in there that are excitotoxins. It's a big industry, and so there's a lot of pressure to keep this story quiet. Now, let's go a little bit into the history of excitotoxicity, how all of this came about. In Japan, they used a flavoring substance for their food called kombu, or sea tangle. And this is a seaweed. When you dry it, you can grind it up, put it in your food, and it greatly enhances the taste of the food. And that's been used for 1,000 years. No one really knew why it enhanced the taste of food until 1908, when a research chemist by the name of Akita examined kombu, and he discovered that the taste-enhancing compound was glutamate. You may have heard of monosodium glutamate, of MSG. Well, that's the active compound, glutamate. So he realized that glutamate had a great potential to enhance the taste of foods. So he made a friendship with the Suzuki Spice Company owner, Suzuki, and together they formed another company called Ajinomoto. The Ajinomoto, which means essence of taste, this company began to manufacture monosodium glutamate, or MSG. By 1933, they were producing about 10 million pounds of MSG and putting it in the food. Now, MSG is a much higher concentration of glutamate than in kombu. So they were suddenly flooding their society with very high concentrations of monosodium glutamate. During World War II, or right after World War II, when we had some of the rations from the Japanese soldiers, they realized that their rations tasted far better than our rations. And so the Quartermaster Corps looked into it and found out, well, the reason it tasted so much better was because of MSG. And they called a conference in 1948 and invited all the major food manufacturers, Libby and Continental and General Mills and Borden, Campbell's, were all invited to this conference. And the quartermasters told them, we have discovered an incredible taste-enhancing compound called monosodium glutamate, or MSG. Well, the major food manufacturers had problems with packaging their foods. They found out, well, we cooked it, after it sits a while or it's in the can, it loses some of its taste. It develops some of the tin-type taste from out of the can, so it has this tinny-type taste. And so this would be an answer. And they found out it would remove all those bad tastes. It would restore and even magnify the taste of the food, so it's just scrumptious. If you put MSG in a soup, it's the most delicious soup you'll ever eat, because it enhances the taste by stimulating certain cells in the brain and the tongue. So from 1948 to 1956, these food processors were adding tremendous amounts of this monosodium glutamate to our foods. And they assumed it was safe because an amino acid, one of the breakdown products of a protein, so they said, well, it's a nutrient, it must be safe, but no one tested it. So from 1948 to 1957, it was being added even to baby foods, because the baby food manufacturer said, oh, let's get the babies to eat, so we'll put it in the baby food. Well, then in 1957, two ophthalmology residents did a research project. And they were studying a rare eye disease in immature mice, and so, in humans, so they would use some immature mice, and they fed them monosodium glutamate. This is the only picture I could find of an ophthalmologist, so. I hope there's no ophthalmologist I'm offending. So in 1957, Lucas and Newhouse, two ophthalmologists, did this experiment, and what they found to their surprise was that the monosodium glutamate totally destroyed all the nerve cells in the retina of the eye. Just wiped them out. And so they wrote up their project, put it in a journal, but it was a rather obscure ophthalmology journal, so hardly anyone read it. And so it sat there for another 10 years until 1968, a neuroscientist came across it while he was doing a project, and he said, well, this would be a good way for me to study the anatomy of the different nerve pathways that go from the eye through the brain. I'll just use this monosodium glutamate to kill the eye cells, and then I can trace it back through the brain. Well, he did that, and what he found out to his surprise was that it not only destroyed the eye cell, but it was destroying critical parts of the brain as well. and that the parts of the brain that was being destroyed resembled some destruction we see in things like strokes, things we see with severe hypoglycemia or very low blood sugar, and like we see in diseases like Alzheimer's disease. And so he immediately realized this is something that's quite serious because this is a food ingredient. And he thought, he told me this story. He said, naively, I thought all I had to do is present the information to food manufacturers and they would take it out. And he said, to my surprise, they just totally ignored it. They said, we don't care. It doesn't make any difference. By then, it was a multi-billion-dollar business. And it solved their food taste problems. So he went to his congressman, and congressman called a congressional hearing, and he presented it before a congressional hearing. Overwhelming. He's a neuropathologist as well as a neuroscientist. He presented his evidence, showed these severe lesions produced in the brain by monosodium glutamate. The food industry was present at the hearing, particularly those who make baby foods. And they saw the handwriting on the wall. If this reaches the public, we're in deep trouble. So they said, well, we voluntarily will remove monosodium glutamate from baby foods because that's a very sensitive time when the brain is forming. So they voluntarily withdrew MSG. Well, not really. For 10 more years, they continued to add it, but in a disguised name. And the amount they were adding to the baby food was the amount that was being used to destroy these brain cells in these animals. Even today, they add excitotoxins to baby foods, and they created a new class of food called toddler foods to sidestep this restriction they put on themselves. And in toddler foods, if you look at it, you'll see several of these excitotoxins have been added. And it's also added to baby formulas. Now, let's look at what I call the big lies of the industry. When all of this starts leaking out, and it was starting to leak out about the dangers of MSG, the industry's reaction was, well, we've had our scientists look at it, and we don't see any problem. Their first solution was, well, the doses used in those experiments were very high doses, and that's not what you're going to see babies eating and children and women. That's not a reason. We're using little tiny doses. That was lie number one. Lie number two was they said, well, even if it does enter the bloodstream and in very high concentrations, the brain has a protective system called the blood-brain barrier that keeps certain toxins from your blood from entering your brain. And it would keep that glutamate out of your brain and wouldn't damage it. And when that didn't work, they went to the third lie. They had a research paper that said, well, we have studied it and found out that if you eat a lot of carbohydrates and sugar, it inhibits this toxicity and doesn't occur, so that protects you. And most people eat meals that have carbohydrates in it, so it's really no problem. Well, let's look at lie number one. Lie number one, saying that these little small quantities. But what we'll see later on is that humans are more sensitive to the toxicity of MSG than any experimental animal. We're 5 times more sensitive than the next most sensitive life form, the mouse. 5 times more sensitive. We're 20 times more sensitive than a rhesus monkey. This is a study that was done by the FASF organization. That's the Federation of American Societies of Experimental Biology. They did a review of all the things that had been written about MSG. And they were going to have a final conclusion about the safety of MSG. The study was conducted and paid for by the FDA, and it had an executive summary in the front part of it that if you read it, you would think they never saw the actual paper itself. So there's no relationship between their executive summary by the FDA and what the paper actually said. The paper reads almost like my book. But that's what the media read. In the bulk of the paper, this was their conclusion about infant formula, was that the amount of monosodium glutamate compound, which they call casein hydrosylates, is a new trick name they use. These babies are regularly consuming large quantities of glutamate in your children. Now let's look at lie number 2. It doesn't penetrate the brain because the brain is protected by this blood-brain barrier. Well, we know that in the human brain, even in an adult, there are certain areas of the brain in which there's no blood-brain barrier. For instance, if we look at the pituitary gland, the posterior pituitary gland, and lining inside, my beam stopped. Always carry a spare. There's certain critical areas of the brain that have no barrier. So anything that's in your blood is going to go into your brain in those areas. These are very critical zones of the brain. So that shows that that part's a lie. And we know that even if you have a normal intact part of your brain with a normal blood-brain barrier, if you have a high level of glutamate in your blood, over time, it'll penetrate even the normal blood-brain barrier. And third, we know that there are frequent causes in which the blood-brain barrier is disrupted. These aren't rare conditions. Strokes, that's not rare. Think how many tens of millions of people in the United States are walking around who have had a stroke. Many don't even know they've had a stroke. We call them mini strokes. They occur in silent areas of the brain. It opens up the blood-brain barrier. Whatever's in your food is going to go through there. Head injury. Millions of people have had head injuries. Hypertension. How many people in this country has high blood pressure? It'll open the blood-brain barrier. Diabetes, a common condition. If you've ever had brain surgery, if you've ever had a heat stroke, when you have a high fever, it opens your blood-brain barrier. Certain drugs that people take for different conditions will open the blood-brain barrier. Multiple sclerosis is a common disease in which the blood-brain barrier is open. That's what happens. Every time they have this onset of symptoms, the blood-brain barrier is opening up, and that's why they have the symptoms. So if they're consuming food with a lot of MSG in it, or NutraSweet, or other excitotoxins, it goes through these openings in the MS plaques in the brain, and they get a lot worse. And what we find in the MS patients is if they consume a food with MSG, they will get worse for days or weeks afterwards. It's a prolonged worsening. Every time they consume it, they get worse again. They go to their doctor says, oh, that's just the natural course of the disease. It's not the natural course of the disease in these instances. They're poisoning themselves. Severe hypoglycemia. If you have low blood sugar, it'll open up your blood-brain barrier. So if you're a diabetic, and hypoglycemia is common in diabetics who are using the insulin, their blood sugar will fall real low. That opens the blood-brain barrier. If they're doing what most doctors in this country tell them to do and use NutraSweet, when they open their blood-brain barrier during one of these spells, it's being flooded by toxins. If you've had a radiation, in other words, if you had X-ray treatments to your head, it opens up your blood-brain barrier. And if you have infections in that area, it'll open up the blood-brain barrier. So we see that these big lies, so far, we've wiped out number 1 and number 2. Now let's look at number 3, that carbohydrates and other food products will block excitotoxicity. What they have found with this is that there was an experiment done by a person who does a lot of defending of MSG, saying it's safe. And he did an experiment on animals in which he fed them carbohydrates, and his conclusion in the paper was the carbohydrates blocked the toxicity. Well, I got his paper and I read it, and that's not what the paper said at all. What the paper found was that if you take high concentrations of sugar or refined carbohydrates, you will reduce the toxicity, but it still causes brain damage. Now, I was interested just how much carbohydrate or sugar does it take to give any protection? Well, according to his paper, it would take about 10 to 15 packs of sugar. These little packets of sugar. You'd have to eat that every time you ate a meal to get any protection. And in his own paper, anything less than that offered no protection. Or you'd have to eat 17 soda crackers every time you ate a meal that had MSG in it to get any protection. So that argument kind of fell to the wayside. So we see that three big lies have just gone by the wayside, but they never give up. They come up with another one. Now these are the disguised names of MSG. Once they found out we were hot on the trail, they said, well, our only alternative is to change the names so the public doesn't recognize it. And this is just a partial list of the names that they have come up with. Frequent one is hydrolyzed vegetable protein. You see that in many, many foods. A lot of soups. You'll see it sold at health food stores. When you hydrolyze a protein, what you do is you break it down, you release its amino acids. One of the higher concentrated amino acids is glutamate. Another one is aspartate, which is also an excitotoxin. L-cysteine is an excitotoxin. Glycine magnifies excitotoxicity. And these amino acids are released and highly concentrated in these different protein products. So if you get textured protein, vegetable protein, hydrolyzed plant protein, there are all kinds of disguised names. Whey protein, enzymes, spices, natural flavoring is a common name they use. Carrageenan is one of the newer ones. It's a highly inflammatory product. They use that experimentally. If you want to produce intense inflammation, you can inject that in an animal and they'll have an intense inflammatory reaction. Good thing to put in foods. Broth, stock. The names just go on and on and on, so you have to know the names to be able to recognize it. And you'll see foods that'll say, contains no MSG, but they'll contain 3 or 4 of these. And the law allows them to do it, because the FDA law says that only if it's 99% pure MSG do they have to put it on the label. So it can be 98% MSG, and they don't even have to put it on the label. They can use one of these little names. And so you're not protected when you see it contains no MSG, or you go to the restaurant and you say, did your food contain MSG? And they say, no. But it contains hydrolyzed vegetable protein or some of these others. And sometimes they don't even know. You'd be amazed how many people in restaurants have no idea that hydrolyzed vegetable protein is monosodium glutamate concentrate. Now, these are the foods that are especially high in excitotoxins. Anytime you use something like a gravy, if you use salad dressings that are commercially prepared, particularly diet salad dressings, they're all high in glutamates. And you'd be amazed the number of people say they go out and eat and they have a salad and they use the ranch dressing and they have this horrible headache. Or they clouded in their thinking. They can't remember. That's because of the monosodium glutamate in the salad dressing. Soups are notorious. All commercial soups use a lot of monosodium glutamate, and Campbell's soup is the worst. Campbell's, I check their labels regularly. I've seen as many as 4 different types of excitotoxins added to a single can of soup. And that's why they taste so good. And what happens when you're sick? Let's have some soup. What do they do in the hospital when you come back from brain surgery or you come back from other kind of surgery or you've had hypertension or diabetes problem? Well, we're going to put you on a diet right now of just soup. All the time. This is the stepwise after surgery. You start with soup and then the soft foods and then you move up to solid foods. That first stage, you're flooding them with excitotoxins and making them much worse. So soups are notorious. Any diet food, when you make diet food, you remove the fat. When you remove the fat, you remove the taste. So the manufacturers quickly say, we can take out the fat, we can put in the MSG, and it replaces it, and they'll eat it. So diet foods, you can just plan on it. If it's a manufactured processed food, it's going to contain a high concentration of excitotoxins. Liquid amino acid preparations. Everybody asks me about amino acid preparations because vegans use this a lot. I get calls from all over the United States asking about it. Anytime you break down a protein to its free amino acids, you're getting high concentrations of excitotoxins. I don't care what they say. You call the company and they say, no, we don't add excitatoxin, no, we don't have MSG. Yes, they do. They say MSG is a salt of glutamate, monosodium glutamate. It's not the sodium that's causing the problem, it's the glutamate. So if they break down the protein and they have a high concentration of glutamate, no, it's not MSG, but it's glutamate. It's the glutamate that's the excitotoxin. In nature, the way God planned things is that proteins are to be broken down slowly in your system. Then your body utilizes it very slowly and it doesn't build up into your blood or your brain. We weren't meant to eat hydrolyzed, broken down protein and free amino acids. Our body doesn't know how to handle that. So when you consume monosodium glutamate, your blood levels can reach 20-fold higher than normal. A brain doesn't know how to handle 20-fold higher normal monosodium glutamate. Neither does the liver, the muscles, or the other organ systems. It wasn't designed that way. Now let's look at, I'm going to give you something that you're probably going to hate, but this is just the physiology of the excitotoxic process. What goes on in a nerve cell when it's exposed to excitotoxins? But this just gives you kind of an overview. Now first, there are a lot of diseases and disorders that are associated with excitotoxicity, and this list is growing every day. They're finding more and more diseases that have anything to do with the brain is associated with excitotoxicity. It seems to be a central process in a lot of different diseases. And this is what we're finding out throughout medicine, is that there's just simple, central things that are causing a wide spectrum of disease. What makes the difference between one disease and another, whether it's cancer or Alzheimer's disease or arthritis, is the excitotoxicity is producing it in different tissues. We know that head injuries, if you injure your head, what happens is, we've known for some time that most of the damage that happens to your brain in the head injury doesn't happen at the time of the injury. That does happen, but usually not. It's delayed several hours. And we've gone through all kinds of contortions trying to figure out what is this delayed damage and how can we stop it. Well, now they've discovered it's excitotoxicity. Because when your brain is injured, it releases glutamate from itself, because normally glutamate is a transmitter in the brain. It's the most common transmitter in the brain. But it's carefully regulated. When you injure your brain, it can't regulate it anymore, and it builds up a high level in your brain and produces the delayed injury that frequently results in severe neurological injury or death. Strokes. When you have a stroke and a block off a blood vessel is going to the brain, it is the lack of blood supply that causes the worst part of the stroke. That just kills a little tiny core of brain tissue. Around that tiny core, the brain starts secreting enormously large amounts of excitotoxins. And that's what causes the devastating aspect of a stroke. If we block those excitotoxins, the stroke is much less. And you can do that with something that God created called food. Hypoglycemic brain damage. When your blood sugar falls extremely low and people go into a coma or die, it's not because the brain cells are starved for glucose. It's because when they're starved for glucose, they release a lot of glutamate, and the glutamate kills the brain cell. AIDS dementia has recently been shown to be caused by excitotoxicity. Migraine headaches are caused by it. Anytime your nervous system is infected with a virus or bacteria, it causes the brain to secrete large amounts of glutamate, and that's what does the damage. Seizures are caused by glutamate excess, excitotoxicity. Most of your seizure drugs, anti-seizure drugs, block glutamate. All of these different things, degenerative brain disease, Parkinson's, ALS, Alzheimer's disease, the hottest area of research is the death of the brain cells by glutamate. It can cause immune suppression, episodic violence, and learning disorders. Now, if you look at a typical brain cell, you have the cell body, or the main part of the cell, and you have this long process called an axon, and at this end looks like a spiny tree in the winter. This is the dendrite. This is where all the different connections are made in the brain. They connect to each other. And dotted on here, you see these little squares here? That's the receptors. That's where glutamate attaches to send the signals down the nerve cell. So glutamate is normal in the brain. It's the most common transmitter, as I said. And its function is to carry information from one brain cell to the next so your brain will work. And it carries out almost everything that you can think of in your brain is somehow connected to glutamate neurotransmitter. Now this is a neurodegenerative process, and basically this is what is the central process for all those diseases I listed about excitotoxicity. That whole long list, this is what happens. And this is similar to what happens in cancer, surprisingly, and arthritis. We're finding that everything is a central mechanism. But in the brain, there's one little difference, and that has to do with this membrane here. It has a little pore in it, a little opening, a channel. This is microscopic. You can only see that on an electron microscope. And what this does is this little pore opens and closes. And glutamate controls the opening and closing of that little pore. Normally, there's very little glutamate outside of that brain cell. I mean, absolutely minute amounts, in millionths of a mole. Okay? And it has to be that way, because if that level rises, it'll kill that brain cell. So your brain goes to a lot of trouble to make sure that glutamate level outside that nerve cell never gets above that 10 to 12 millionths of a mole. And it does that by a process where anytime glutamate's out there, it combines with a special transport protein, and that whisks it away and puts it in a cell called an astrocyte and stores it there until it's needed. Only when you're going to have a transmission of an impulse will it release it, and when it does, it breaks loose of the transport protein, attaches to its receptor, opens up the hole, and calcium pours into your cell. And then it whisked away again, and the hole closes. So it's only open for a millionth of a second, just enough to let a few molecules of calcium in. Once that calcium is in, it starts triggering these processes. And these processes normally, if it's just a little bit of calcium, what it does, it makes the nerve fire its impulse. If something happens and there's too much glutamate and it opens that hole up for too long, too much calcium gets in. If too much calcium gets in, then too intense of a reaction of these different processes take place, and it'll produce an inflammatory reaction in that cell with these inflammatory chemicals. It'll produce what we call free radicals, which are just very toxic chemicals that bounce around the cell, oxidizing all the components of the cell. One of the components that really damages is what we call the mitochondria, and that's the little part of your cell that produces almost all the energy that you use for everything, whether it's walking, moving, thinking. Mitochondria supplies the energy for everything. These free radicals generated by too much calcium damages that mitochondria, so it can no longer produce its energy the way it's supposed to. If it can't produce enough energy, the cell dies. It activates a gene called a p53 gene, which is the suicide gene in your cell. Cells are pretty smart. God made them that way. If this cell is damaged too bad by all these processes, and the cell knows that it cannot survive, it'll activate that gene and go ahead and kill itself. We call that apoptosis. And that's what too much calcium coming in will do. We also know that if some of these products build up, they'll inhibit this transport protein so that more glutamate will start building up. So it's a kind of a cyclic process that just keeps going until the cell dies. Now, note with the knowledge that if too much glutamate out here is toxic, and it doesn't take a lot to make it toxic, does it make a lot of sense to add it to your food? Knowing that it transfers through the blood-brain barrier and will enter the brain, which we have proof of. Now, when we look at excitotoxin sensitivity, three things we see that are very important. One is that human is 5 times more sensitive than the next most sensitive life form on Earth, the mouse. And we're really 20 times more sensitive than a rhesus monkey. Newborn babies are 4 times more sensitive than adults. So if you're pregnant and you're eating food that contains a lot of MSG, that is passed through the placenta into the baby and damages the baby's brain at a time that brain is being formed. And they're 4 times more sensitive than an adult would be. Why are the babies so sensitive to MSG? It's because their brain enzymes that normally protect them are immature. They haven't formed yet. Their blood-brain barrier is immature. It hasn't completely formed yet. And babies and toddlers frequently become hypoglycemic, which magnifies excitotoxicity. Now, what do these excitotoxins do inside of the nervous system once they get in there? Well, we know that they can actually alter how the brain forms. That's what's so bad about the little children. We know that when the mother is pregnant, during that last trimester and during the first 4 years after birth is when most of the brain is forming. All these little pathways have to connect, and they have to connect in a certain way. All these dendrites are growing and branching. These synaptic connections are taking place. And that is very sensitive to glutamate. Too much, it destroys these pathways or make them grow in the wrong direction. We know they can destroy certain groups or collections of these brain cells called these nuclei, like the arcuate nucleus, ventral medial nucleus, or the hypothalamus. It can destroy it. This nucleus is the most sensitive area of the entire brain. It was interesting during the hearings on the toxicity of glutamate, one of the neuroscientists that was working for the glutamate producers made this statement, well, so what if it destroys the arcuate nucleus? We don't know whether it does anything or not. But at the time, we knew the arcuate nucleus was a very important nucleus in the brain. It's very vital. Another interesting thing is that less than toxic doses, that is, a dose that won't kill a cell, will alter its physiology. It'll make the cell overreact, so if it's a cell secreting hormones, they'll secrete too much hormone. If it's one that has to do with consciousness, it may cloud the consciousness. If it affects memory and it's overstimulated, it may alter your ability to remember. One of the ways that excitotoxins kill is by producing free radicals. Excitotoxins are very powerful free radical generators. They make these cells produce all these destructive free radicals that destroy the cells. And one of the interesting things we found out not too long ago is that it impairs the ability of glucose to enter the brain. The brain is almost totally dependent on glucose for its energy supply. Glutamate interferes with the entry of that fuel to the brain. So when you're consuming a diet high in MSG, it interferes with the ability of your brain to get the fuel it needs. Now, let's look at the MSG babies. These were the animals that were first exposed to glutamate. They all had certain characteristics that is repeatable, and this has been repeated ever since this first was discovered. This has been done over and over. We find that the organ weights of the animals are very small. It causes atrophy or shrinking of various organs. The ovaries, testes, adrenal glands, kidney, spleen, pituitary, they all are smaller than normal, significantly smaller. We find that the animals were all grossly obese. And we'll talk more about this tomorrow, but the obesity is similar to what we're seeing in human society now. With this growth, we're talking about adolescent obesity. All the kids are real obese, and it's difficult to control, and a lot of the adults are finding trouble controlling their obesity. We find that it's almost impossible to diet off this type of obesity, and it's almost impossible to exercise at all because it alters the part of the brain that has to do with obesity. Abnormal reproductive functions are very common with MSG toxicity in these babies. When they become adults, they have very small litters. And this is true even for the males. If you expose the males to MSG, they become infertile or have difficulty procreating. We find that MSG is frequently associated with unprovoked rage, overt aggression, and antisocial behavior. This is almost always consistent in these MSG-exposed babies. And I'm not just talking about while they're a baby. This is when they become adults. This lasts the entire lifetime of the animal. When the animal gets older, it's filled with rage. It won't associate with the other animals. Impaired cardiovascular responsiveness. You know, when you run, your heart speeds up. Well, that's impaired. It doesn't quite work that way anymore. We find that animals that are exposed to MSG have very high triglyceride levels, cholesterol, and very low density lipoproteins. And this persists for a lifetime. This puts them at high risk of having heart attacks and strokes, arteriosclerosis. Abnormal hypothalamic pituitary adrenal axis, that is how the endocrine system works, is permanently altered in these animals. So we see some rather devastating effects to exposing animals when they're babies. Now, this is reproducible in every animal species. This is not just peculiar to a mouse. Chickens, horses, sheep, every animal that this has ever been tried on has produced the same thing. So this is a universal effect of monosodium glutamate, and these are all serious things. These aren't feeling bad. Too many people associate MSG with the Chinese restaurant syndrome. And I hear people frequently say, oh, well, I don't get that. I'm not sensitive to it. It is not an allergy. It is not a sensitivity. It is a toxin. Everybody's sensitive to a toxin. You're sensitive in various degrees. But what we'll see later is that it produces its effects silently. You pay the price later. And you may not associate it with it because you don't think that something you did or fed your baby or when you were pregnant is going to cause them to have a heart attack when they become 30 or 40 years old. Now, we said the brain is forming all these pathways, and this is just an example of the complexity of these connections. Everything has to be exact, and the brain is constantly, during this period, the last trimester of birth, inside the uterus, and 4 years after birth, the brain is constantly remolding itself to get it just right. Glutamate is important in that process. It's used for that process, but it has to be an exact level. If it's too much, it ruins the connections. If it's too little, it ruins the connections. And these connections are permanently going to be that way. This is a three-dimensional view, so you can see that these connections are three-dimensional. They're not on one plane. They have to be in 3 dimensions connected. It's an incredibly, incredibly complex process. And anyone who doesn't believe in God has seen this. I can't imagine why you don't believe in God, because there's no way for us to explain how this happens. And these pathways go the whole length of the brain, so they have a long way to go, and they have to be connected just so. And glutamate can permanently alter how these connections and pathways are formed and connected. This is the temporal lobe of your brain. You've heard Vicki talk about the hippocampus. It lies right in here, and it has everything to do with your memory. The temporal lobe is very important. We call it the integrative cortex. It connects to all other parts of the brain. It takes everything you've ever seen, done, heard, smelled, and it correlates it. So it's very critical. This is one of the most sensitive areas of the brain to MSG. It's one of the most sensitive areas of the brain to a lack of glucose. This is just the synapses, how the brain cells communicate to each other, to show that even that's a very complex process. It's not a simple process either. That is formed when you're a baby as well, and it's a very exacting process. Now, they knew early on that there are certain endocrine changes that occur with exposure to MSG in these animals. One of the most obvious, of course, is the effect on reproduction. And they looked at the different hormones, and they found out that it altered estrogen secretion. It altered the estrogen receptors in the hypothalamus, which controls your estrogen cycle. It also had an effect on testosterone for the males, so that while they were exposed as a child, it not only affected the nuclei that control these different hormones to be regulated and released, but it altered the pathways in the hypothalamus that made up the control system. And so when these animals became older, their control system was totally different than a normal animal. And this is what's happened in humans. So that when that child's exposed as a small baby or a toddler, when he becomes adolescent or older and finds they have reproductive problems, they can't have babies, they're infertile, or they have other reproductive problems. They can have trouble with their menstrual periods. They can have polycystic ovaries. So there's all sorts of problems related to hormones that we can trace back to MSG that you normally wouldn't expect. Because when you see the child at age 20 or 25 and they're married and they're having problems having a baby, who would have thought that it was because what that child's mother ate when she was pregnant with the child? But we have good experimental proof that shows it is connected. We found that even lesser doses, a little small dose of MSG, can actually cause an early onset of puberty. Loss of growth hormone pulsation, that little nucleus that the doctor said he didn't think it had any function. its primary function is the control of growth hormone. That's why all these animals are short, because it suppresses the pulsating release of growth hormone. And of course, we said it can alter the pathways. Now let's look at the hypothalamus. The hypothalamus of your brain, if you had to pick a part of your brain that you said was probably the most sensitive to any injury, it'd be the hypothalamus. Doctors kid about it being the seat of the soul. It's about the size of your fingernail on your little finger. It's not very large. But it controls an enormous amount, and you cannot live without a hypothalamus. Major injury to the hypothalamus, you're going to die, short the intervention of the Lord. If we look at the functions of the hypothalamus, we see that it controls all of the endocrine system, or your growth hormone, thyroid hormone, adrenal hormones, cortisol. All of these things are controlled through the hypothalamus. It controls your sleep-wake cycle. Tells you when to wake up, tells you when to go to sleep. If you have an injury of the hypothalamus, you'll stay awake all the time, or you'll sleep all the time. So it's very important. It controls your hunger and satiety. It tells you when you're hungry. It tells you when you need to eat. And this is part of the thought of anorexia nervosa, if they have a problem in the hypothalamus. We know that it controls the autonomic nervous system. In other words, all these things automatically makes your heart beat so you don't have to think about it. Things that make your intestines move along with peristalsis so you don't have to think about it. Those are automatic reactions, parasympathetic, sympathetic system. That's controlled through the hypothalamus. And we know that it is a major part of what we call the limbic system of the brain. That's the part of the brain that has to do with your emotions. It has to do with love, anger, fear. Is regulated through the hypothalamus. And if you give MSG to animals, you can produce intense fear or you can produce intense anger. And lastly, we know, and this is something fairly recently, that the hypothalamus controls immunity. There's a whole field of psychoneuroimmunology. And this is part of what, if you're under stress, your immune system's depressed, you're more likely to get cancer, more likely to get infected, more likely to not recover from your infection or your cancer because your brain, your emotions connects to the hypothalamus and that controls your immunity. We find that in experimental animals, if you take that hypothalamus and you expose the animal to MSG, it will cause a suppression of immunity that will last the entire lifetime of that animal. And if you think about that in humans, if you have a baby exposed to MSG during these critical periods, that could affect their immunity forever, so that they'd be at higher possibility of getting infections or cancer. If they got a cancer, they have more difficulty recovering from it. So you're talking about some profound life-altering changes here. Now, one of the things that's really intrigued me is the effect on intellectual development. And if you look at the brain, you see this enormous complexity. We've been studying the brain probably for the last 70 years intensely. We're just getting a glimpse in the window. It is so enormously complex. There's nothing in the body even approaches the complexity of the brain. But what we find is that early on is that when MSG exposed babies are tested, they find that they're intellectually impaired. In fact, this doctor said that it appeared as if the animal was intellectually retarded. And this experiment, which is a two-part experiment, was very interesting. She took animals that were pregnant and exposed them to MSG and then tested the offspring and found that the offspring initially looked perfectly normal. And when they did this simple little test for intellectual function, they passed with flying colors. But when they tested them for more complex problem solving, the animals were severely impaired. Now, if you transpose that to a human, what that means is if your child is born after exposure to MSG or after being exposed to MSG after birth during that first 4 years, you say, well, the child looks normal. He's going to the different little grade schools and seems to be able to learn his ABCs and count and learn his name and do simple spelling. Seems to be intellectually normal. But then when he gets into higher school and has to do higher math has to do logic, has to do intense cognitive functioning. They're impaired. Now, who is going to look at that and say it was due to MSG exposure when the baby was a child, when no one will let this story out? No one knows this was done. The second part of the experiment, she was curious why this happened. So she measured the neurotransmitters in the brain in these offspring to see what happened, and found that there was an 80% reduction of a transmitter called acetylcholine in the frontal lobes of those offspring's brain. Now, acetylcholine is absolutely vital for learning and memory. There was also a reduction in a neurotransmitter called norepinephrine. Norepinephrine is what allows you to pay attention, to concentrate. So if you cannot concentrate on a topic, then you're not going to remember. And this is what's happening. I'm going to have to move a little faster than I planned on. I always talk longer than I plan on. Now let's move to adults. So we know that children are 4 times more sensitive. Look at some adults. The brain is at risk for these different reasons. Now, one, the brain has one of the highest concentrations of polyunsaturated fats. It's about 50% polyunsaturated fats. Polyunsaturated fats are easily oxidized. You're all familiar with rancid, things becoming rancid. Well, that's what oxidation of a fat does. Well, in your brain, you have a very high concentration of oxygen, one of the highest concentrations of any organ. It consumes 20% of all the oxygen in your blood, even though it's about 2% of the weight. So it's consuming enormous amounts of oxygen in the face of those polyunsaturated fats. So they become very easily oxidized. Brain normally has iron in it, but the iron is protected by being attached to a protein. As you begin to get older, that iron is released, and you get free iron in your brain, which is very dangerous. The older you get, the more iron is released. Iron is one of the most powerful generators of free radicals, and that's thought to be one of the reasons why the brain starts aging, and you have these problems with brain aging. And aged brain cells are more sensitive to free radical damage than a young brain cell. Much more sensitive, about 4 times more sensitive. This is just some of the changes that occur when your brain ages. You lose some of the receptors. The cell membranes change. They become stiffer. It's difficult to get the nutrients into the cell as you get older. The cell cannot produce as much energy as it used to. There's accumulated free radical damage over your entire life, so that you begin to damage the DNA, damage the protein, damage the lipids, and this accumulates throughout your entire lifetime. And remember, we said the way that excitotoxins kills the brain cell is by generating lots of free radicals. So you're speeding up this aging process significantly when you're exposed to those substances. Now we know that there's 3 things that are associated with increased excitotoxicity. We already said immaturity of the brain makes you 4 times more sensitive. Second is energy deficits. Anytime a brain cell has difficulty generating energy, it becomes infinitely more sensitive to excitotoxins. So if you have low blood sugar, if you're running a race and you didn't eat properly and your blood sugar's falling, if you're dieting severely, if you have a disorder of your mitochondria and you can't produce the energy, whatever the cause of a lack of energy in that brain cell, it's going to magnify the excitotoxic process. And it can magnify it as much as 100-fold. It can magnify it so much that even a normal concentration of glutamate in your brain can be toxic. Magnesium deficiency is the third thing. Magnesium deficiency in this country is very common. A recent review showed 75% of people are magnesium deficient. Magnesium protects that little pore where the calcium comes in. It closes the hole. If you take a human being and you make them hypomagnesic, that is, you remove the magnesium, they will have a seizure, and they'll go into a coma. And before that, they'll become psychotic. And this has been done or seen many times in clinical patients. And if you give them magnesium, they turn back to normal, if you do it in time. And that's because magnesium prevents this excitotoxicity process. This is just the cycle we've already talked about, that excitotoxins cause free radicals. Free radicals damage things inside of the cell. It damages the DNA, the proteins, the lipid membranes. So it does a lot of damage to your cell. And that damage accumulates over a lifetime. And that's basically what aging is. And we see that certain types of DNA are more sensitive than the others. Your mitochondrion has its own DNA. It's 10 times more sensitive than the DNA you normally think of in the nucleus. Older cells have DNA damage at a rate 4 times higher than younger cells, especially after age 70. So the older you get, the more sensitive you are to free radicals. So therefore, the more sensitive you're going to become to MSG and other excitotoxins. Now let's look at Alzheimer's disease. Alzheimer's disease is a very complex disease, but we're beginning to get a handle on it. The most common thought of the etiology is that it's excessive excitotoxicity in the brain. Now what triggers that, it's a different story. We know that the loss of energy in the brain precedes Alzheimer's disease by as much as a decade. You can scan the brain of people and you can find out that these areas that are going to be affected are already losing their energy supply, even though they're perfectly normal at the time. 10 years later, they come down with Alzheimer's disease. And that's because, as we said, when you lose that energy, you magnify the excitotoxic process. Now, I'm not saying that Alzheimer's disease or any neurodegenerative disease is caused by eating MSG. It's probably more complex than that. It may be the release in the brain. But we know that Alzheimer's disease can be significantly aggravated by MSG in the diet because, number one, Alzheimer's disease damages the blood-brain barrier. You lose your barrier. You're at low energy. Your cells can't produce energy. The cells are damaged by free radicals, so they're more sensitive. So in a state, if you have Parkinson's disease or if you have Alzheimer's disease or any of these degenerative diseases, you're at a lot more risk. Parkinson's disease, one of the first things we see occur in Parkinson's disease is the loss of a substance called glutathione in the cells that are affected. This is a molecule that protects you against free radicals. It's very, very important. It is lost years, decades before you ever develop Parkinson's disease. Then you begin to accumulate iron in those cells. And we said iron is a very powerful free radical generator. So the cell can't protect itself against free radicals. You increase the free radicals with the iron. Then the energy begins to drop. There's this particular loss of energy of 42 or 47% loss of complex 1 energy generation in the mitochondrion. And the cell dies. Well, it's an excitotoxic process that's triggering all of this. There's also, you've heard of haloperidol, Haldol, which is used to help some people sleep, well, Haldol will produce the same amount of depression of complex 1 energy generating enzyme as you see in Alzheimer's disease. In Parkinson's disease. These are the common things you see. The important ones you need to know is people that develop these degenerative brain diseases all have low vitamins in their brain, particularly antioxidant vitamins. Very low magnesium in all of these diseases is very low. Cellular energy is low in all these diseases. High iron content, high free radicals, all this oxidation in their cells, and high intracellular calcium. There's an obsession with taking calcium in this country. They tell the elderly, you've got to have this calcium, eat these Tums, take this calcium supplement. As you get older, your cells have more and more difficulty keeping the calcium out. You don't want to flood the brain with more calcium to speed up the process. This is just some of the enzymes that are known to be defective in these two diseases, Alzheimer's disease and Parkinson's disease, and we'll talk about that tomorrow. We've talked about that. Here's where we end. This is how glucose gets into your brain. This is a blood vessel. This is the brain cells. The glucose has to go from the inside of the blood vessel into the brain to get to the brain cells. But it doesn't just diffuse like it does in the rest of the body. The brain has a very tight control of anything that gets into it. And what happens is the glucose attaches to a transport protein and it carries it into the brain. We know that as you get older, this glucose transporter is defective. And it continues to become more defective. And Alzheimer's disease is very defective. And this leads to the last concept, that is the concept of brain hypoglycemia. And that is that because of this defective transport of glucose into the brain, which remember is magnified by MSG, the brain doesn't have enough glucose where it is, but the blood can have normal glucose. And that causes the brain to be hypoglycemic. So if you go to the doctor and he draws your blood, he says your blood sugar is normal. But that doesn't tell you what your brain is doing. Your brain can be extremely deficient in glucose. And it has been remarked by several observers that Alzheimer's disease closely resembles when you see people having hypoglycemia. So it may be that there's a chronic hypoglycemia developing of the brain. That magnifies excitotoxicity, opens up the blood-brain barrier, toxins get in, and it keeps the process going. And lastly, the point I want to emphasize is something that Vicki was saying. Your entire metabolic processes is programmed from birth. And they found in multiple studies that if you look at the weight and size of a baby when it's born, that's going to affect its metabolism from then on. If it's small and thin and unhealthy to begin with, it will alter the metabolism for the rest of that child's life. So whatever you do early on, MSG or whatever, to alter the metabolism, alter these nerve cells, it's going to affect that child from then on. And that's why I wrestled with this book. I said, knowing what I know, I can't keep this silent. People have to know this. This is so frightening and so scary, and it is in all the food that people need to know. So we'll end there since they're flashing cards at me.
We hope you've enjoyed this presentation and have gained a blessing from the information presented in it.
I loaded it up this morning.
You know, that looks just like our salt.
What I'm going to talk about is something that probably most of you know very little about, the details. You may have heard some of the things that I'm going to talk about. How many here know what an excitotoxin is? Okay. So it's nice to see that so many people are coming to hear about something they have no idea what it's even about. But you're curious because primarily the second part of the title of the book, Excitotoxin, the taste that kills. And I'm sure you're curious as to what taste can kill you. Well, we're going to find out. If you could dim most of the lights except for this one over the podium, you can see the slides maybe a little better. An excitotoxin is exactly what its name says. Most people know what a toxin is. A toxin is a poison. Exciting is something that excites you, causes excitation. And an excitotoxin basically is any substance that causes brain cells to become very excited. And they start firing their impulses very rapidly. And they fire so rapidly that this cell will become exhausted and die. This occurs over about an hour's period. So if you take some brain cells and you put them in a petri dish and you expose them to these excitotoxic substances, the cells start firing real rapidly. But they look normal during that 1 hour period. You look at them, they look perfectly healthy. And then at 1 hour, they just suddenly die. And this is going on in your brain if you take these excitotoxins into your body. It does the same things. There's particular cells inside of your brain that will become very excited. And they'll become excited to the point that they'll die. But it's not all the cells of the brain, it's just particular ones. Now, in Matthew 13:34 through 37, it says, "For out of the abundance of the heart the mouth speaks. A good man out of the good treasure of his heart brings forth good things. And an evil man out of the evil treasure brings forth evil things. For by your words you will be justified, and by your words you will be condemned." And we're going to find out how that pertains to the subject of excitotoxins. Because at the present time, excitotoxins, the subject of excitotoxins, is the hottest idea and item going in the field of neuroscience. That is the study of the brain and the nervous system. Every journal that has anything to do with the brain and the nervous system is filled with articles about excitotoxins. Every research laboratory that is dealing with the diseases like Alzheimer's disease, Parkinson's disease, Lou Gehrig disease, Huntington's disease, all these terrible diseases of the brain, the number one thing that they're talking about is excitotoxins. But with all this flurry of activity and the fact that they have named this the decade of the brain, that we're going to concentrate all this money and all this effort in studying how the brain works and solving the problem of these terrible diseases of the brain. Despite all of that, hardly anyone in the general public has ever heard the word excitotoxin. And that's not by accident. It's because the number one source of excitotoxins in our society is in your food. And it's not in your natural foods. It's being added to your food by the industry that processes foods. And they're adding it in very large concentrations. And we'll see exactly what these excitotoxin substances are and the various deceiving methods they use to keep you from knowing they're there, and what they try to do to those of us who are trying to tell you they're there, and what they do to you. Now, what I have found out since I wrote this book, and this book was a very difficult thing to write. I went through a long period before I ever decided to do it, because I was warned by people who had dealt in this area before when I told them I wanted to write a book. One of the persons who first tried to start in this crusade, he said, well, that's fine, but let me warn you something. You're going to come under attack like you've never dreamed of. He said, Ralph Nader, most of you I assume know Ralph Nader, the consumer advocate. He became interested in this at one point, just one segment of it. There's a lot of pressure to keep this story quiet. Now, let's go a little bit into the history of excitotoxicity, how all of this came about. In Japan, they used a flavoring substance for their food called kombu, or sea tangle. And this is a seaweed. When you dry it, you can grind it up, put it in your food, and it greatly enhances the taste of the food. And that's been used for 1,000 years. No one really knew why it enhanced the taste of food until 1908, when a research chemist by the name of Akita examined kombu, and he discovered that the taste-enhancing compound was glutamate. You may have heard of monosodium glutamate, of MSG. Well, that's the active compound, glutamate. So he realized that glutamate had a great potential to enhance the taste of foods. So he made a friendship with the Suzuki Spice Company owner, Suzuki, and together they formed another company called Ajinomoto. The Ajinomoto, which means essence of taste, this company began to manufacture monosodium glutamate, or MSG. By 1933, they were producing about 10 million pounds of MSG and putting it in the food. Now, MSG is a much higher concentration of glutamate than's in kombu. So they were suddenly flooding their society with very high concentrations of monosodium glutamate. During World War II, or right after World War II, when we had some of the rations from the Japanese soldiers, they realized that their rations tasted far better than our rations. And so the Quartermaster Corps looked into it and found out, well, the reason it tasted so much better was because of MSG. And they called a conference in 1948 and invited all the major food manufacturers, Libby and Continental and General Mills and Borden, Campbell's, were all invited to this conference. And the quartermasters told them, we have discovered an incredible taste-enhancing compound called monosodium glutamate, or MSG. Well, the major food manufacturers had problems with packaging their foods. They found out, well, we cooked it, after it sits a while or it's in the can, it loses some of its taste. It developed paper. When I did my first big conference on excitotoxins, the reporter was sitting in the audience. I presented the case for excitotoxin dangers. He attentively listened, and he told the person next to him, who happened to be a friend of mine, that this is the most unbelievable thing I've ever heard in my life. He said, this is terrifying. When the article came out in the Chicago Tribune, he quoted some of the things I've said, and then the rest of it was quoting the industry representatives, which said things that the writer knew was not true. And so I wrote him a letter. And I said, you sat in the audience, and you heard all of the evidence I had, scientific evidence, that their refutation and defense of its safety was not true, yet you still wrote this article. I said, I can't tell you what to write, and I know the pressure you're under, but you're going to have to live with the thought of all the damage you've done to children, pregnant women, everyone in this country because of what you've done. And it's because his newspaper was heavily advertised in by General Mills and all the food manufacturers in Michigan. So there's enormous pressure to keep this story quiet. Luckily, I've been on the 700 Club several times. They have carried the banner in this. I've been on about 7 times. Hard Copy did a thing on the NutraSweet and the pilots, airline pilots that were drinking NutraSweet that were having seizures. They were becoming so confused they couldn't figure out how to land their airplanes. We had one pilot just totally could not figure out, and his co-pilot had to land the plane. There's over 600 pilots now who have come secretly to organizations to tell their stories of the problems with NutraSweet. I've done about 40 syndicated radio programs. That's basically the way we're getting this story out, is through the radio programs and the 700 Club. They're the only people. And the ones that are most interested, I find, are the Christian radio stations, because they're not afraid. Health food magazines generally will not touch this story because they sell these things in their health food stores and call it health food. Now, a lot of things in the health food store are fine, but they're putting some items in there that are excitotoxins. It's a big industry. And so he was so browbeaten and so destroyed by this industry, he said he would never touch it again. And I talked to his attorney, Jim Turner, who told me this story. He said they were through with it. And this is a man that took on General Motors. So it's something that is not a light thing to take. So I was warned. Said they have hundreds of millions of dollars they will spend to keep you from getting this story out. They will threaten lawsuits. They will intimidate you in every way imaginable. So if you do this, be prepared. And so when I wrote the book, I said, what I'm going to do, I'm going to make this argument so tight, so well referenced, that no one can refute it reasonably. So I spent a long time going through hundreds and hundreds of research papers, interviewing the person who coined the term excitotoxin. And then I wrote the book. And ironically, all these terrible things that were supposed to happen never came about, except a couple of times. But I was able to handle that because I had some secrets that they didn't know, that God let me know about. Interestingly, no major publication will write about this. Your major magazines will not carry stories about it. I've never been interviewed by a major magazine. I've had 60 Minutes call me and wanted to do a story and spiked it. That means they cut it out. I had a writer for the Wall Street Journal editorial page who dared to write about how the story was spiked, and they took him off the editorial page and put him in a non-public office. Had one of the talk programs that's kind of like Hard Copy that's no longer around. They did an interview. We set up the story. The reporter worked with me. They fired her and canceled the program. The Chicago Tribune news